In this video, I'll give you a brief introduction to the new simulation tool in Radiant. Before we start, let's check the version number. I'm on 376, so make sure you are as well. And then let's go to the Data Manage tab and load a state file. Choose File, and we'll go to Conley Fisheries. And this is in the simulation directory for full-time and flex evening. That's in session 8. So Conley Fishery. This is an example from the book. Specifically, it's on pages 211 through 217. And so you should read this before you actually watch the video so you'll get a better understanding of the parameters of the simulation. Now, one of the characteristics of simulation is that we don't actually have data to start with. We have some general understanding of some of the parameters of the problem, but we don't have data. And so simulation is actually going to generate the data for us, given what we know about the problem. So the types of variables involved here, and again, you'll have to read the case up to get the details, is we've got some constants, we've got some discrete variable, and we've got a normally distributed variable. There's other options as well, but we don't need them for this particular simulation. The binomial is one that you'll use, for example, for the Ontario Gateway case. All right, so 3 different types of variables. Once you specify those, there'll be input options. So we've got our input for constant, for discrete, and for a normal. And the constant is about the cost of operating the boat on a daily basis. And so we'll label that C because that's also the notation that's used in the book for consistency. And so C, and specify a value of 10,000. So that's the cost of operating the boat for a day. Once we hit plus, it gets added to this text box down here. And so once it's in the text box, it's going to be used in the simulation. Now in this case, we've accidentally added a second version, which we don't need. So we can press minus to actually remove the variable again. All right, so we've got our constant C, which is $10,000 per day. We've got a discrete variable, which is demand. And so demand can vary at this particular port between 0, and so that's specified in here, all the way through to 6,000. So we specify all those values with a space in between. D is our demand. We specify a name. And then in the last box, we've got the probability of each of the demand conditions. So again, we've separated everything by a space, and they're all in this particular box. Once we're done, we press plus. If we made a mistake or we want to make some edits, we can press minus, and then it's going to remove the variable. Right? So if I press minus, it's clear. We can add multiple versions. There's not really much point in that in this case. Let's just make sure we have one option. And then finally, price at the Rockford port has a normal distribution according to the case, with a mean of 365 per pound and a standard deviation of 0.2. So I've added that to the text input box, and so price is going to be a part of the simulation, demand is going to be part of the simulation, and cost. All right, some other inputs, and this is just for consistency. You should put in a random seed. A random seed is just a starting point for the simulation and will help to ensure that the results that you get are consistent. It'll also make them more comparable to what you see on my screen and more comparable across others in your group and when you submit the homework. So it's not particularly important, but it's a good idea for consistency here to just use a particular random seed, a starting point for the simulation, and I'm just using 1, 2, 3, 4 here. We're going to do 1,000 simulations, 1,000 simulation runs, so it's going to be 1,000 draws of all kinds of different numbers. And because we specified a name in this particular box, it's called SimDat. Once we actually run the simulation, a file will be generated which has data in it generated by the simulation. All right, so that's all the inputs on the sidebar here. Where things get a little more interesting is once we start to specify formulas. So the first row here is actually a comment that I've added, and you can add comments to the simulation formulas by just using a pound. In this case, we use 2 pounds, but you can use 1 or 3 or however many you want. The first equation is probably the most important, which is something about earnings that the fisherman is going to have. And so it's been labeled F. Again, that's for notation, consistency with the book. What are the earnings a function of? Well, they're a function of the price that the fisherman is going to get and a function of demand at the Rockford port. Now, the interesting about the demand at the Rockford port is that it's going to vary. It's going to vary as we specified here in the discrete distribution, discrete variable, between 0. Sometimes he'll not be able to sell anything if he goes to that port, and he might be able to sell up to 6,000. Unfortunately, his boat only has a capacity of 3,500. So he'll sell at max 3,500, or whatever demand is. So if demand is smaller than 3,500, he'll sell that, else he'll sell 3,500. Okay? And the function pmin is a function in R, which basically looks at each row in the simulation and compares the value that is generated for D to 3,500 and picks the minimum value of that. Okay? If you want more details about some of the functions you can use in a formula, click on the help file. Here we go. So it talks about the different inputs, it talks about formulas, and the different types of formulas that you can generate. Now hopefully the formulas will give you, at least conceptually, somewhat of an idea similar to Excel. Instead of cell references here, though, we're using variable names. So PR stands for the price at Rockford, D stands for demand, 3,500 is the capacity of the boat, we know that, and C is the cost. Right? So his earnings are going to be the price times whatever he can sell at the particular port minus the cost of operating the boat. All right, so we're going to run a simulation. It's going to generate 100 draws of the different variables that we specified and then combine those in a way according to this formula that will lead to an estimate of earnings. Now, a couple of things we're interested in. One is how likely is the fisherman to make more than $1,375, which is what he would expect to make if he takes his catch to the other port. And so we've specified here is an equation where we say, okay, what's the likelihood that F is going to be larger than 1375, and that information is going to be stored in this new variable that I've labeled R versus G, where R is the Rockford port and G is Gloucester. You could use any type of name here, you could call it blue, but something that is descriptive is probably handy. And I've also specified another equation which looks at the probability that the earnings are going to be lower than 0. He's going to have losses when he goes to the Rockford port. This is really all the inputs that you need for the simulation. Again, this is for 1 day because it cost him $10,000 per day to take out the boat. And so once we've specified these different inputs, we can click Simulate, and we get our results. So the first block here is just some descriptives related to the parameters we specified for the simulation. We have a 1,000 simulation. We started with a random seed. The data is saved into the file simdat, constants, and so on. Then here's the summary output. It shows us the value for the constant, which is C, 10,000. We already knew that. And here's where it gets a bit more interesting. These are the randomly generated variables and their combinations to form a new random variable called F, which is earnings. We see N is 1,000. There are 1,000 simulations, hence N is 1,000. The average for the price of Rockford, is of course very close to the value we specified for the distribution and the standard deviation as well. We're not as interested in that, of course, but we want to get a better understanding of what is the overall earnings going to be. So here we have demand, and here are our earnings F. And so on average, the fisherman would expect to earn $17.65, which compares favorably to the price he would get, or the total earnings he would get if he went to the other port. However, there's also quite a bit of variation here. Right? There's almost no variation, or assumed to be no variation at the other port, but at Rockford there certainly is. And so we'd be interested to know, if he were to go to the port a lot of times, what would be the probability that he would earn more at Rockford than at the other port. And so down here we get our logicals, and logicals are things that evaluate to true or false. These are the ones up here. Both of these evaluate to true or false. The first one is true if F is larger than 1375, else it will be false. And the second one will evaluate to true if F is smaller than 0, and else to false. So how many trues do we have out of 1,000? 807 times out of 1,000 in the simulation. The earnings at Rockford are better, or almost 81%. However, there are certainly some cases where the earnings are going to be negative. He's going to lose money because maybe not everything was sold, or the price was too low, or a combination. So we've also got some histograms here. This shows us the distribution of prices distribution of demand, which is a discrete distribution, and then here is the distribution of earnings. Most of the time, it's going to be making positive income if he goes to this port. However, sometimes there are some negatives, and they can be quite substantial to the point where he doesn't actually sell anything and is just out the cost of the day for the boat. So that's kind of part one of the simulation, where we're just doing one run. We get some really interesting information here, a better understanding of how the different variables are connected and the possible earnings, given the assumptions we've made about the different variables. But what we might also want to do is kind of repeat the simulation and see what things would look like on an annual basis. And so to do that, we have basically a simulation here for one day. We have to repeat that simulation 365 times. And so of course we could run the simulation, save the data, run the simulation, save the data, and so on, and do that a whole bunch of times and then try to aggregate across it, but that would be a bit of a pain. And so that's why we have the repeat tab. So in the repeat tab, we're basically resimulating, doing that a certain number of times, and trying to come up with an overall result. Okay, so it's going to aggregate across a whole bunch of repetitions of the initial simulation. So we have to first choose the variables we want to resimulate, and we can choose all the variables or only specific variables. And in fact, in the case from the book, the Gentle Entler case, we might not want to simulate all of the specified variables, the random variables. In this case, I'm just choosing price and demand. I could also choose C, but C is a constant, so it's not actually going to make any difference if I do or don't in this particular case. All right, what are we interested in output? We're interested in our earnings, F, and we have to decide how we're going to group the data. So we can group it by runs, in which case we would get 200 estimates, or we could group it by simulation, which is actually what we want to do here. So we have 1,000 simulations, and we're going to repeat that 200 times in this case. And so we want to get 1,000 observations where values are summed across 200 different repeated simulations. I actually said earlier 365 days, but obviously he's not going to be able to go out 365 days with his boat. Let's say we specify that he's going to take out the boat 200 days a year to see what things are like, and go to the Rockford port every time. Okay, so we could choose different functions to apply. In this case, we're going to do a sum, because we want to sum across the 200 days, or 200 different simulations that we do. And again, the data is going to be saved to a file, sim.repeat. There's also going to be another file that's going to be saved, which is going to be sim.repeat_sum, which has the summarized data across the 200 simulations. All right, so we can specify formulas up here too. For example, we could talk about the probability of particular earnings. So let's call that P large. We can choose whatever we want. And let's say something like F is larger than, I don't know, 200,000. So what's the probability that he's going to earn more than $200,000 a year if he goes out 200 days in the year? So we can hit repeat and see what results we get. All right, so you can see that there are 1,000 simulation draws, repeated 200 times. We're going to group the data then by simulation. And so you can think about the results as a table where we have 1,000 rows and 200 columns, and we're going to create the sum per row, right? So it's going to be across 200 days, if you want to call it that. And that's going to be our estimate of the annual earnings, assuming he goes out in about 200 days a year. Summed across the 200, we have a question here about the probability of making more than 200,000 a year. And here are our summaries. So we have here the sum of F across 200 different repeats. And it turns out that the mean across those variables, across the simulations, is going to be about $366,000, which seems quite lucrative for a fishing operation with a single boat. But maybe he's very good at what he does. All right, so 366,000 is the kind of the expectation. Of course, there's quite a bit of variation around that. This is the standard deviation across 1,000 simulations. minimum, maximum, and so on. This is the maximum that he would make according to the simulation. All right, the maximum he would get out of all the different simulations that we ran. The probability that he's going to make at least $200,000 seems exceptionally high. Right, so it's almost equal to 1, so 999 out of 1,000 simulations, he actually earned more than $200,000. And so here's the distribution of earnings F, and we see that there's definitely quite a bit of variation, but he's likely to make quite a nice income if he goes this route. All right, so that's basically all that there is to the simulation tool. It's quite straightforward. The trick, of course, or the skill comes in figuring out what the inputs should be, coming up with reasonable assumptions, specifying those appropriately in the different inputs, and then, of course, tying them all together with these formulas. Right? The formulas are quite straightforward. They're basically just like simple profit equations. You can relate variables together. You can specify these logicals, which is just like in filters. If you go to data and view, you might apply some of these functions in filters. The difference being that you have to specify a variable name here that's going to contain the information generated by the formula. A tip on variable names: don't use spaces, don't use symbols. You can use underscores, but other than that, it should just be letters and perhaps a few numbers. Keep it simple. Same thing with these data sets that you generate. You can look at these, and I'll show you one in a second. Don't use spaces. Underscores are okay, but other symbols you shouldn't use. And you can simulate. You can also put these simulations in the report feature if you wish. And then finally, what I'll show you is just what the data looks like that was generated. So this is SimDat, which is from the initial simulation. You'll see that there's no variation in that constant. These are the different prices that were generated. Quite a bit of variation. Demand, earnings. If we sort by F earnings, we see that there's certainly some days where he's losing $10,000, which is the cost of operating, so he actually didn't sell anything. And then here are the logicals I referred to earlier, generated through the formulas. When is the price at one higher than at the other, or the earnings from one port higher than from another? That's one of the data sets. The full or biggest data set we're going to have is that for the repeated simulation, where we in this case have 200,000 rows. Remember, the simulation had 1,000 simulation with 1,000 simulations, and then 200 repetitions. So in total, 200,000 rows. And then finally, there's a summary version of this where it's been aggregated over the 200 repetitions. Do that 1,000 times, and so in this one we have the earnings annual earnings across 200 days of fishing, and we have 1,000 observations of that. All right, this should be enough to get you started. If you have particular questions, make sure to post those on Piazza.